Hello, hello. Today we are going to continue factoring. We are talking about a specific pattern today. We actually learned this pattern in chapter 6. You might remember that I told you that you really want to know this particular pattern because it's going to be useful in chapter 7, and here's why. Because we're using it in chapter 7. That is the pattern called difference of squares. The reason we call it difference of squares, first of all, difference means subtraction. So you must have a subtraction sign, and it must be in between two things that are squared. That's why they named it difference of squares. And it follows this pattern right here. So that means that you have to be able to figure out what is being squared to get the first term and what is being squared to get the second term. That's how you're going to determine what goes in your parentheses. One of the parentheses will have a plus sign. One of them will have a minus sign. It does not matter which gets which. If you want the plus sign in the first parentheses, put it there. If you want it in the second parentheses, you can put it there. But you have to have one with a plus and one with a minus. That's how this pattern works. So if you look at the first example, we do have a minus sign, so that takes care of the difference. 9x squared is a perfect square because I can multiply 3x times itself to get 9x squared. 25 is also a perfect square because I can multiply 5 times itself to get 25. So the 3x, because it came from the first term, it is going in the first part of the parentheses. And the 5, because it came from the last term, it's going at the end of the parentheses. And again, one of them gets a plus, one of them gets a minus. That is all there is to the difference of squares pattern. So let's take a look at these examples down here. It says factor each binomial if possible. I like that it says if possible. So you notice in some of the previous sections we were looking for a GCF, which we're going to continue to do. If we had a trinomial, we were doing the sum and product charts, and some of you guys realize that, hey, I do a sum and product chart, and sometimes it doesn't work. I can't figure out two numbers that work. And so what happens? We have been calling that prime. So not everything is going to factor. Sometimes it just doesn't factor at all. And so if that's the case, then we call it prime. So let's see what's going on. In example number 1, we have m squared minus 81. So already we're on the right track because we have a minus sign. What can we square to get m squared? Well, that's easy. You would square an m. And what can we square to get 81? Also not terribly hard. You would square a 9. So according to the pattern, the m is in the front of each of those parentheses. The n is going to be in the back of each of those parentheses, and one of them gets a plus and one of them gets a minus. Well, let's see if that's actually accurate. So how do we do that? Do you remember what we did? We can FOIL it out. Remember, I encourage you guys to always FOIL it, even if you just do it in your head, to see if your answer is accurate. So let's see. What would we get for first? M times m is m squared. Outer would be negative 9m. Inner would be positive 9m. What's going to happen to the negative 9m and the positive 9m? They will cancel out. Then last would be negative 81. So yes, that works out perfectly. All right, number 2. We're already good with a minus sign. What can you square to get 25t squared? Well, for the 25, you would have to square a 5. And for t squared, you can square a t. Looking good. What can you square to get 6? Somebody probably thinks 3, but that's not accurate because 3 squared would be 9. Well, would 2 work? No, because 2 squared is 4. So guess what? There's not a nice whole number integer that's going to fit right here. So this one is not possible. And so we're going to say that it is prime. We cannot factor it. All right, number 3. Got a minus sign. Looking good. What can we square to get 8y squared? Well, the y is easy, right? You would square y, but what about that 8? 8 is not a perfect square. So we can't figure out a number for this. So if we can't figure that out, we are done. Now there might be somebody in here saying, well, I could figure out the second one, right? 1 is a perfect square and it would be 1 squared, and you're right. But if you can't figure them both out, then you can't do it. So we're done with number 3. Number 4, got the minus sign in the middle. What can we square to get 9h squared? Well, 3h would work. What can we square to get 64? That would be an 8. So according to the pattern, what do you guys think is going to go in the front? Hopefully you were thinking 3h. That means 8 is going to go in the back of each of those parentheses. And again, one of them needs a plus, one of them needs a minus, and you can FOIL that out to see if it works, and it does. All right, so let's try something that maybe are a little bit more challenging. So number 5, what can we square to get 9x squared? Well, that one's not too challenging, right? 3 squared is 9, and x to the second power is x squared. Let's talk about the next one, 100y to the 4th. Let's start with 100. What can you square to get 100? That one is not terribly hard, right? 10 times 10, that's 100. But what about the y to the 4th? What could you square to get y to the 4th? Would y work? Nope, because y to the second power is going to be second power, or y to the second power is going to be y squared. What about, though, if you plugged in a y squared? So you remember we learned about powers and properties and all that stuff in chapter 6. Remember this one was called power to a power? What do you do when you have a power to a power? You multiply those together. That would turn into y to the 4th. Ding, 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 we have a winner. So let's see what this looks like. In the front of each parentheses, we're going to put the 3x. And in the back of each parentheses, we're going to put 10y squared. And one of them gets a plus, and one of them gets a minus. And we're done. Oh, Shane, I can hear you now. Fractions, Miss Wingard, no. And fractions are so fun. So let's check them out. Now, if fractions are overwhelming to you, and sometimes they are overwhelming to some people, no big deal. Look at each number separately. And what I mean by that is look at the numerator and then look at the denominator. So that's what I'm going to do. What could I square to get a 1? I could square 1, right? 1 squared is 1. Now let's look at the denominator. What could I square to get a 9? 3. So I'm going to put 3 in the denominator. So the answer for that is if I squared 1/3, I would get 1/9. See how easy that was if you just look at the numbers in their separate locations. So look at the numerator, figure that one out. Look at the denominator, figure that one out. There's your fraction. But don't forget your variable because we also need a g, right? Okay, so we have a fraction over here, 4/25. Again, let's look at each one separately. What could you square to get a 4? A 2. So 2 is going to go in the numerator. Ooh, whoops. And then in the denominator, what can you square to get a 25? That's easy. A 5. See, fractions are not that bad. All right, so what's going to go in the front? Well, 1/3 g is going to go in the front of each. And then 2/5 is going to go in the back of each. And then one needs a plus, one needs a minus. Ta-da! We're done. I can hear Taylor now saying, see, Shane, that wasn't that hard. Can y'all hear that with me? I do miss y'all. Wish I could see your faces. Although you should be pretty glad you're not seeing me because I look a hot mess these days. Okay, so here we go, number 7. So what can we square to get 49w squared? 7 and a w. What can we square to get 16? 4. All right, looking good. What's going to go in the front? 7w. What's going to go in the back? A 4. And then one needs a plus and one needs a minus. Pretty easy. All right, of course I threw in some more fractions because why not? Okay, here we go. So we got 49 over 16. So again, let's break it up and look at each number separately. What can you square to get a 49? That would be 7. What can you square to get a 16? That would be 4. Not too hard. Now let's look at the variable. We have c to the 4th power. What could you square to get c to the 4th power? Would c work? Nope, because that'll get you a c squared. What about c squared? If you square c squared, will you get c to the 4th? Yes. So that one is done. Now let's go to the second one. What could you square to get 81? That would be a 9. What can you square to get 100? That would be 10. And then what variable would you square to get d squared? That would be d. See, I'm imagining that William is like already on example 14 because he zooms through these while we're doing them in class. He's probably doing that right now too, huh? Okay, so what's going to go in the front? Well, both of them in the front are going to get a 7/4 C. And then in the back, they're both going to have a 9/10 D. And then one needs a plus and one needs a minus, and we're done. Okay, super important. That's why it's in big letters. Always, 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 always look for a GCF first, because let's look at number 9. So it has a minus sign, which is great. Can we think of a number that we could square to get 50? No, we can't. Which means right now, this is not a difference of squares. But if we look for a GCF first, that might help us out. So they both don't have variables. However, both of these numbers are even, which tells me that they're divisible by 2. So we're going to take out a 2. Remember, that means you're dividing it out. So 50, and now we're dividing out a 2. That turns into 25. 98, again, we're dividing that by 2. That turns into 49. And then you still have your d squared. Now, let's ignore the 2 for just a moment and ask ourselves, what can we square to get 25? And that's easy. That's a 5. And then what can we square to get 49d squared? Well, to get the 49, you would need a 7. And to get the d squared, you would need a d. And now we can use the pattern. What's going to go in the front of the parentheses? A 5. What's going to go in the back? A 7d. One of them needs a plus, one of them needs a minus, but don't forget your GCF. It is a part of the answer. And this would be the final answer. So again, if we had not taken out the GCF first, we would not have recognized that it truly was a difference of squares. So you've got to look first for a GCF every single time. So let's use that same knowledge for number 10. Do we have a GCF? Sure do, because those numbers are both even. That means they're divisible by 2. So if we divide that out, 2 divided by 2 is 1, so this is going to be a 1c squared minus 32 divided by 2 is 16. Is this a difference of squares? Well, it's certainly a difference. What can you square to get c squared? That's easy, just a c. What can you square to get 16? That's a 4. So according to the pattern, we're going to have c in the front. We're going to have 4 in the back. One needs a plus, one needs a minus. Don't forget your GCF, because that is a part of the answer. So you want to always make sure you are looking for that greatest common factor. Number 11. We have 75x cubed minus 12xy squared. Let's talk GCF. So what do you guys think? Well, they're not even, so 2 can't go into both of these. 5 can't go into 12, but it could go into 75. What about 3? Do you guys remember the divisibility test for finding out if something is divisible by 3? You add your digits, and if that number is divisible by 3, then the number you're looking at is divisible by 3. So in other words, 1 plus 2 is 3. Can 3 be divided by 3? Yes. So that means 12 can be divided by 3. Let's try this one. 7 plus 5 is 12. Is 12 divisible by 3? Yes. Okay, so definitely a 3 can go into both of those. Let's look at the variables. So they both don't have y's, but look at what they do both have. They both have x's. Now this one has 3 of them. This one has only 1 of them. So how many could we take out if this one has 3 and this one has 1? We can take out just 1. So the GCF is 3x. Okay, so we're going to divide it out. So 75 divided by 3 is 25. Here we have x to the 3rd power. That means we had 3 x's multiplied together, but we're taking 1 of them out. How many are left? 2. Got my minus sign. Now 12 divided by 3 is 4. I have a single x. I'm taking that single x out, but it's going to leave me with y squared. So we took out our GCF. Now we have a difference because it's a minus sign. What can you square to get 25x squared? You could square a 5 and an x. What can you square to get 4y squared? You can square a 2 and a y. So according to the pattern, 5x is going to go in the front of each parentheses. 2y is going to go in the back of each parentheses. One needs a plus, one needs a minus. Don't forget to bring down your GCF. Keep that in mind. Don't forget, bring it down. It's part of your answer. All right, let's look at number 12. I threw a fraction in there because fractions are fun. All right, let's look at these fractions. Okay, so I'm going to try to make this easy on y'all because I know some of y'all don't really like fractions like I do. Look at the top numbers. We have a 7 and we have a 28. Can you think of what the GCF for 7 and 28 be? In other words, what's a number that they're both divisible by? Well, 7 is only divided by 1 and 7. 28 is divided by many other numbers, but is it divided by 1 or 7? Yeah, it is definitely divided by 7. So we can take a 7 out. Now let's look at the bottom numbers. We have a 4 and we have a 9. Do they have a GCF? Well, 4 breaks down into 2 times 2. 9 breaks down into 3 times 3. Do they have anything in common? No way, Jose. So there's nothing in the bottom, the denominator, that we can take out, but we can take out a 7. So we're going to take out a 7. All right, let's see what that does to this problem. The denominators aren't going to change because remember we said they didn't have a greatest common factor, so we're not taking anything out of the bottom. Let's look at the top. 7, and we're going to divide out this 7 is going to leave you with a 1. And then don't forget your n squared. So all we did was we took out a 7 from the numerator, and that left us with a 1. We're going to do the same thing here with this 28 because we're dividing this 7 out of the 28, and that leaves us with a 4 just in the numerator. Because again, the denominators didn't change because they did not have a GCF. Only the numerator did. Okay, so we have a difference. What can we square to get 1/4 n squared? So remember I told y'all, if you're frustrated with fractions, you just look at each thing separately. Let's start with the numerator. What can you square to get a 1? Duh, right? 1. 1 times 1 is 1. What can you square to get a 4? 2. And then what can you square to get n squared? N. So 1/2 n is that one. Now let's look at the 4/9. Again, we're going to look at each part separately. What can you square to get 4? That's a 2. What can you square to get a 9? That is a 3. So, got the 2 parentheses. The 1/2 n is going to go in the front. The 2/3 is going to go in the back. One needs plus, one needs minus. Don't forget your GCF because it is a part of your answer. So don't let fractions throw you off. You just look at each part separately. Okay, so I got a couple challenge problems for you. I would really like for you to pause it. Obviously, I'm not there to see if you're pausing it. So I'm going to use the honor system and hope that you're pausing. And now I'm going to keep going. Okay, so number 13. Do I have a GCF? Well, variable-wise, I don't, because G's and H's don't have anything in common, right? 32 and 162. They're definitely both even, so I can take 2 out. So 32 divided by 2 is 16, and then I still have the G's. 162 divided by 2 is 81, and then I still have the H's. So I have a difference because I have the minus sign. Let's look at the first term. What can I square to get 16g to the 4th? Well, I need a 4, obviously, but let's look at the variable. Would a regular g work? Nope, because then I would have g squared and not g to the 4th. What about a g squared? Would that work? Yes, because now I would get g to the 4th. So now let's go to the second term. What can I square to get 81? 9. What can I square to get h to the 4th? Does a regular h work? Nope. What about an h squared? Yep. So according to the pattern, my 4g squared goes in the front of each parentheses. My 9h squared goes in the back of each parentheses. One of them gets a plus, one of them gets a minus. Don't forget the GCF. It's a part of your answer. Now, if you got that, I am very proud of you. But if you stopped there, that means your final answer is not correct yet. You might be wondering, what do you mean if I stopped there? Well, we took out a GCF. Look at this guy. Can't do anything else with him because he's got a plus sign. He's not a difference. But look at that guy. So it's a difference, okay? And we haven't seen this happen in any of our examples yet, but look at what we have. Could you square something to get 4g squared? Yep, you could square 2, and you could square a g. Could you square something to get 9h squared? Yep, you could square a 3, and you could square an h. This is the first example we've seen today where we end up with another difference of squares. None of the other ones have had that. Look back up here with me real quick. We have a difference, but that is not a perfect square, and that is not a perfect square. Same thing happens here. We have a difference, but those are not perfect squares. But sometimes we end up with another difference of squares. So let's see what's going to happen according to our pattern. So in the front of the parentheses, we're going to have 2g. In the back of the parentheses, we're going to have 3h. Now again, one of them gets a plus, one of them gets a minus. So what we just did was we took this 4g squared minus 9h squared, and we broke it down into this. You still have the 4g squared plus 9h squared. That didn't go away, it just didn't factor any further. And you still have the GCF of 2. And so this whole thing right here would actually be your final answer. Now number 14 I think is a little tricky. So if you didn't have any idea how to start it, it's totally fine. So look at what we have. We have a minus sign, which already lets me know we have a difference. Look at this. This is a perfect square because we have something being squared. Over here, what's being squared? E. So right here, I'm just going to kind of write that down. This is something being squared, and that is E being squared. So let's see how this is going to look. So in the front of the parentheses, we're going to put the C plus D. In the back of the parentheses, we're going to put the E, and then one of them gets a plus, one of them gets a minus, and that is our final answer. That one was a thinker, so if you had no idea how to start that one, that's okay. That one is definitely a challenging one. But number 13, I'm hoping you at least got partway there. I would like to believe that everybody could get this far We just had never seen prior to now an example that could be taken a step further. So as you're working on your homework, things to think about. You need to constantly be looking for a GCF. That needs to be the very first thing you do in every problem, is look to see if you have a greatest common factor. Then when you factor your problem, you always need to ask yourself, can it go any further? This one was able to go further, and so you must go further. It's just like if you have a fraction and you forget to reduce, you get points off. Same thing here. If you don't factor fully, you get points off. So always look to see, can I take it an extra step further? And if I can't, then I'm done. And if I can, then do it. So you guys have a homework assignment. It is in the book. Tomorrow, though, there will be a video on 7.1, or not 7.1, 7.7 with another homework assignment in the book. We have a busy week as far as Zoom sessions, so we're going to have a Zoom session on Wednesday where we're going to be doing practice together. We're going to have another one on Thursday because Friday you guys have a test. This test is going to cover 7.1 through 7.7. So this is going to cover prime factorization, finding a greatest common factor, and factoring it out, using the sum and product method that we worked on last week with the trinomials, using the difference of squares pattern we learned today, and then tomorrow we're learning one new lesson. But tomorrow will be the last lesson before Friday's test. As far as the Zoom sessions go, I am expecting everybody to attend. All of you should be there on Wednesday, on Thursday, on Friday. So go ahead and put that on your calendar or keep it in the back of your mind. Make sure y'all are looking in RenWeb and looking at both lesson plans and homework notes, because you don't want to miss anything, because I think sometimes some of y'all look in one area and you forget to look in the other area and you miss assignments. So just make sure y'all are keeping up with those, and I will be talking with y'all on tomorrow's video for the last new material for this week before the test. So I will talk to you tomorrow.